So we've got a question here where we've got a parametric curve and it's defined as x equals t over 2 plus 2 and y equals e to the t minus 1, and it's defined for t is a real number. Now we want to calculate the shaded area of this graph, and this graph represents the parametric curve defined like this. So what we're given is a point A where it intersects the x-axis. We've got this point here at x equals 3.5. So we want to calculate this shaded region here between the x-axis and the curve. So what we want to do first of all to solve this, it's obviously going to be an integral question, as in the area under a curve. So the integral of a parametric curve is defined as the integral of y dx dt with respect to t. So that's our beginning points, and then we need these 2 points here. So we're given this point A, that's our lower bound, and the upper bound is for x equals 3.5. That's kind of where we've got to start from. So we need to get these, if we're going to do the integral in terms of t, we need to get the t values for these. So that's going to be the first goal, and then we can find this dx dt. So let's do that. Let's first of all find this upper bound. So let's do it over here. So if x equals 3.5, 3.5 equals x, so then x equals this. So then that equals t over 2 plus 2. So subtract 2 from both sides. So then I've got 1.5 equals t over 2. So we can see clearly here that t equals 3. So that's t equals 3 when x equals 3.5. So let's start off our integral down the centre here. So we've got t equals 3. So that's our first building block. Now this point A. Now we don't know much about this except for it crosses the x-axis at this point. Now where a curve crosses the x-axis, that's where y equals 0. So this is our y. So now let's deal with that. So y equals 0, and 0 is e to the t minus 1. So let's solve for that. So add 1 to both sides, so e to the t equals 1. So in that case, for e to the t to be 1, anything to the power of 0 is always 1. So in that case, t equals 0. So that's our lower bound taken care of. So t equals 0. Okay, now y we've got, y is this, it's e to the t minus 1. So I'm going to put that in there in a bracket. So e to the t minus 1, so that's that. Now we need this dx dt. So let's take care of this. So x equals t over 2 plus 2. So we need the derivative with respect to t of t over 2 plus 2. So the derivative of that, the 2 becomes 0 and t over 2 simply becomes a half. So that equals 1/2. Okay, so now let's put that into here for my dx dt. So we've got 1/2 and then we've got dt. Okay, so now we can just solve this integral from t equals 0 to t equals 3 and see that as our area under the curve. So now let's do the next line of working. So we've got 0 and 3, that's our t values. E to the t minus 1 times a half, so let's bring a half out to the front. E to the t minus 1 dt. So this is pretty straightforward integral now. E to the t, in terms of t, that's just going to be e to the t. So I've got 1/2 e to the t, and the integral of minus 1 with respect to t is minus t. And that's calculated from 0 to 3. So wherever I see a t, I'll put a 3 for the first part, and then where I see a t, I'll put a 0. So let's do that. So I've got 1/2 times, now e to the t, so e to the 3 minus 3. So e to the 3 minus 3, that's wherever I see a 3. And now subtract that when e is 0, so when t is 0, e to the 0 minus 0. Okay, well this just becomes 1 inside here. E to 3 minus 3 is as it is. So I've got e to the 3 minus 1. So that's e to the 3 minus 4. And then times a half. So then that becomes e to the 3 minus 4 all over 2. And that is our answer to the area of the shaded curve. Okay.